We're almost 2 minutes after, and then we'll give this a start. Okay, I'm Doug Vernier, and I'll be presenting this particular webinar, one of 3, with Kate English, and that'll be coming up. Her presentation will be coming up a little bit later. So we'll start this by telling you a little bit about what we're going to do on the webinar, and this slide here that I hope you all can see indicates kind of the order of events. So I'll let you read that, and then we'll move on to our first order of business. And I want to change the slide here, and why is it not changing? There it is. All right, so we're going to actually be dealing with these rules. These rules are the ones that you should know. If you have not looked at these recently, they're worth going through again. About the 20th time you read them, they start to make more sense. The FCC has an interesting way of writing things to be quote-unquote as clear as possible. So here we're looking at 73205, where the FM allocation process has 3 zones. Each of those zones has certain classes and antenna height maximums and ERPs. And power and antenna height, 60 dBu equivalent for each one of these. That's the distance to the 60 dBu for each one of these different classes and zones. 73207, the minimum separation distances for the class of stations, and 73215, overcoming minimum separations using contour-to-contour short spacing. All of this is taken care of automatically by FM Commander, but you should really know what it's doing, and that's why I'm suggesting that you really get into the rules here. The next one here, just to mention to you, is a 70 dBu covering the city of license for commercial non-reserved frequencies. That is not necessarily a hard and fast rule because of the allowance of Longley-Rice studies, which where you can show the 70 dBu study shows that there is coverage over. Now, the rules say the entire principal city, but in fact, they'll let you do it if it's not a new allocation for 80% of the population and 80% of the coverage. 73509, contour-to-contour U-to-D protections, the mapping here in FM Commander, and of course the table, we call it the interference table, counts all of that up as it goes along. 73515, the NCE stations, that they're a little different than the commercial stations. They must provide a 60 dBu to at least 50% of the principal city. And there's no such requirement or standard for translators. 73525, NCE protection to full service channel 6 TV. Now that in fact is not so onerous as it used to be because there's not so many channel 6 TV stations on the air anymore. So that isn't as, but that's built into the program, an analysis that gives you an idea of where you stand with regard to channel 6 TV interference. So moving to the next slide, and now buttons work. Highlighting the new features. Here's a tour of the Essential FM Commander screens. I know that many of you work with this program daily and you know most everything, but you may have a few questions, so we hope to answer those questions now. So we'll pull up FM Commander and move it around so that we get a good sized screen here. Now I've loaded the program with auto load turned off. You set that up in the setup defaults. So it just loads a blank screen. And we're going to start this tour of the of what the program does in the various screens by actually doing a study. So we'll do a quick study. I'm not going to load one. We're going to, and I always use these icons up here because they're just much faster than the menu. And so we'll pull the icon up for the reference screen, and I'm going to put in Cozy, which is an Iowa station. In fact, I think most of our examples here are Iowa stations. And we'll accept it by double-clicking, and it will run the study. And I'm going to do a contour-to-contour study, and I could do a minimum up 3 and down 3 in the IFs, but I will, in fact, do the full study. A little bit larger file, but not much really longer time. We're going to include Class Ds and Class Ls. We don't need those, but we'll include them to make sure you know what you're doing, so you don't step on somebody that might be a high patron of your radio station in one way or the other. And we'll go into compile, and I'll compile this in my temporary folder, and watch the paint dry here for a second as it compiles the full study. All right, now immediately this screen pops up with this new feature telling us that we do not necessarily meet the 70 dBU requirement of covering the principal city. So we'll actually pull in the map and I clicked call here to pull in this map, and we'll look at the city of license and see how much of it is covered by the 70 dBU. And the nice thing about FM Commander is that you don't have to type anything after you do the original study. You just click this or click that, and it comes up. And I'm just going to show you quickly, if I right-click this 70 dBU, I can pull it out of the clutter that it's in and move it around. So that's what I just did. It shows the pattern, and if you click into the pattern screen, of course, you can get in to the actual pattern, changing that. Maybe if we have enough time, we'll get into working with the patterns, but I'm not sure about that at this point. So here's Anamosa, and we are definitely not covering it. Now maybe since this was a study we just did, they very likely have used Longley Rice to show the cover of the entire city. And you can look at the profile if you want to, and that'll give you another indication of how well you're covering whether Longley Rice would work for you or not. And you'll notice that you do have a line of sight barely. You kind of come over the top of this hill here, but you do have a line of sight, which would mean that Longley Rice would likely work, but maybe not be excessive. So you would actually use probe to come up with the Longley Rice analysis, not FM Commander. In any event, here's where we are, and that's I'll close this now, and we'll go back to looking at our screen here. And if you don't know the abbreviations of the screen, the colors, if you go into Help and click Abbreviations and Color Coding, this screen will give you all of the abbreviations. And I'm not going to go through all these. They're there for you to use, some of which you will see on the screen as you look at it now. And if you actually want to go into color coding, you click yes, and this will give you what all of the colors mean. And some of those are pretty obvious and some are not. So we're looking at, because this is a short-spaced station, this is a 73215 station which had the short space, as a C3, we're actually looking at the interference and the outgoing interference and the incoming interference columns. Now, when the actual spacings are met, then you're not going to see interference shown. What you see in in these, and I don't know if you can see my cursor, but let's say the third line down, you have a minus 0.2. That is the distance in kilometers of the overlap of the incoming contour. So you're going to be receiving interference, I should say, from WRQT, and that isn't allowed. So there's a couple ways we can handle that. I'll get to that in a minute. Where you see the spacings, the R and the M, the R indicates the required spacing, and the M is your margin. So the required subtracted from the distance gives you the margin. So when you're in the interference mode, as we started out, you will see these R's and M next to the program, and that indicates standard spacings. If I'm going to just change over to the standard spacing screen, and if we click into when we click into that, let's see. Oh, here it is. We get the actual spacings, and you can see that we've got two here that are contour overlaps that we're going to have to protect using 73215. The WRQT also shows a 0.6 kilometer overlap. I have the spacings toggled down to rounded, and if I click that little icon up there, that's turning off the round down. And of course you can use round down as long as you don't round down past 0.5 on these FCC minimum separations. So that's what we're seeing here when we look at the minimum separation screen, and that's what this screen is, the tabular screen. So I'm going to go back now to the interference mode, where we have two columns, one showing outgoing and one showing incoming interference, except when the spacings are met, and they're met, and you'll see this little double caret over on like KQMG-FM has these double carets here, and that indicates that the spacings have been met, so there's no need to look at the contour-to-contour relationship. So in that case, you're seeing the FCC requirement and the actual margin that you have. The up arrows indicate that these two stations have been up arrowed, maximized as per 73215, which means they have to have the maximum power and antenna height for their class. And if we look these stations up, I'm going to click one and look it up, you'll see that here's a C2 with 50 kilowatts and 150 meters. But if you look down below, you'll see the default power, which actually picked one here that isn't a good example, because the default power is also 50 kilowatts at 150 meters. Let's look at the other one, WRQT, I'm sorry, WZAT. Here's WZAT. We've maximized it by reducing its HAT from 117, which it is default, to 100 meters, and increasing its power from 4.4 kilowatts to 6 kilowatts. Well, that's part of 73215 procedure. You have maximized it or max classed it. Now you have to protect that contour, and that's what we'll be showing you here shortly. However, we do have this overlap, and if we look at that overlap, I'm just going to quickly look at the map of that overlap. You may not see it. You can actually see, here it is down here with the word Manchester, and I have my cursor there, if you can see that. I'm going to recenter the map there, and we're going to zoom in, and we can zoom in by simply changing the scale. And I'll zoom into a 1 to 1,000,000 scale. These are scale approximates. And we should be able to see more closely the overlap. And if you look carefully here, you can see the overlap. I don't know how big your picture is, so I'm going to zoom in a little bit more. Oops, wrong scale. Here we go. Zoomed out, actually. Here's the zoom feature built in, zoomed in, and one more here at 1 to 250,000. And you can see the overlap fairly clearly right here. So we have a 0.2 kilometer overlap that we would have to deal with. But right now I'm going to show you well, I wouldn't say it's a trick. It's completely legal. If I click up here, and any one of these values, by the way, can be changed by a click of the mouse. So if I wanted to change the power, I just click in the 18 kilowatts, I can put in a different power. I'm not going to actually do that right now. I'm going to click the terrain database that I'm using, and we're going to move down here to the Globe Terrain database rather than the FCC database. And I'll do that, and I can, if I just want to do it for this setting, I can just close this, and it will be that it will use that terrain database for this setting. Now, what happened to our overlap with WRQT? That shows us that it's 2.5. My goodness, we jumped from an overlap of minus 0.2 to a clear space of 2.5 on the incoming. And I don't need to show you that on the map, but you'll actually see that on the map, because actually I'm going to go to the map in a minute. So what gives with this? Can we use this database? Yes, you can. It's actually one of the databases on the FCC website, and it is a legal database to use as long as you use it under the FCC's guidelines. I always submit an FM over, which is the tabular UDDs that are available and the special HATs along the protected contour. That tabular shows the actual HATs and the above average terrain values, and the FCC says they'd like to see that when we don't use a standard, their standard FCC database. So, but that's we always include that no matter which terrain database we use FM over. So what we're looking at now is KZAT and KRQTs. They have been maximized, but wait a minute, we have a brown up arrow on WRQT. What goes with that? Well, if you look up your abbreviations and you go into color coding, you'll see that that means that when you look at the local HAT, and that's the one that's calculated with the global terrain database, it's going to be different than the one that was applied for when that application went in for WRQT. Which one is right? Well, I'm not sure which one is right, but the FCC probably can be convinced that the one you're using, the globe terrain, is the one you need to use. So this up arrow, when it's brown, means that there's a 5 kilometer difference between what the FCC has and what the program determines is the actual local HAT. So what we're going to do here is actually change the overlap to the local HAT, and we can do that by going into the Tools menu and using the local calculated. Now, we haven't changed it. It's still using the FCC's, but here we're going to use the local calculation. So we're going to use the global terrain database to determine basically their center of radiation, which is the value that is being used for their HAT. So we determine their HAT, we back calculate to determine what the center of radiation is, and we change that, and you can see the change that will occur here when you use local HAT. All right, so now the up arrow has changed to blue, which means that we have given that particular record the local HAT. So if you're using the Globe Terrain database, they say you should use all of the that database for all of the values that you derive. We've used it before with the FCC value, and it worked fine. If you want to be specific, you can say, well, we've recalculated and used the global database to determine the distance to contour along those points, and we end up getting the 0.4, which is shown up here. So if you one thing we can do here, and I said I was going to show you the map, the map here. This is the value of the terrain localized for WRQT, and if we move to the other train database, and this will be recalculated here, we'll see that we're localized here. We're still, so we have to take localizing off. You go to Tools menu, take it off, and we're back to where we started, or close to it. We're still up arrowed here. And with the, I went to the SRTM, so that's why it didn't look right. So let's go over here to the FCC. All right, we're back to where we started with the 0.2. You can actually see those changes on the map, so I won't go through any more of that. Now, we've got some crossouts here. What are these? These pink crossouts. Well, that means that the station there does not have to be protected. So you can actually get rid of those if you want to. And to do that, you can go up to Settings and suppress all secondary allocations, and they'll just drop out. It gives you a much cleaner screen to deal with. So let's see. Now I wanted to show you the short space on another screen we have here. So we've looked at this screen, and we've looked at some of its abbreviations, and we've looked at the mapping screen, which showed us the coverage contour, and it showed us the contour to contour relationship. Now, if we go into and I click that circle icon up there, I clicked this icon, that'll take you into the separations mapping screen. And that's going to show us the actual separations. And I want to tell you a little bit about this screen. This would indicate to us that the actual area to locate is in the area shown right here. And I can actually, if I go into settings and go into fill separations, I can actually show you the space. There's the area to locate. Well, they're not in that area because they're short spaced. So take that off now. Sometimes it's easier to see where your area to locate is when you do that. Now, I wanted to talk about these. This is a multicolored contour, and what that means, not contour, but circle. These are the minimum spacing circles plotted as if you were flying over. They are not the coverage contours, okay? These are the FCC rules minimum spacings. Now, here's one that's a 73-215. That means that you can actually go into this area deeper. You don't have to stay out of it as long as you can protect it under 73-215. Now, one of the things I wanted to show you here was the auto short spacing. Notice that here we have an overlap short spacing. Now I'm going to show you the table so that you can get an idea where we've converted or changed over to the minimum spacings table. So we're looking at a different spacings table, separations. This is the separations table. This one we looked at before. This is not contour to contour. And this shows you we have this -16, and that's here. So we're into the clear space, move this up here so you can see it, of KZAT. And we have to protect KZAT in that direction, and KOZY has done that with its directional antenna. Now, if we go to auto short spacing, it does something else here for you. Let's change that. Did any change occur? Yes, it did. I just didn't see it. All right, auto short spacing brings back this circle to the transmitter point. And if we happen to move any closer to Cedar Rapids, there's a couple of issues. First of all, serving the city of License, which is Anamosa. And secondly, we have moved inside the minimum separations that you must have in order to apply short spacing, 73-215 short spacings. So we couldn't move any closer to Cedar Rapids or we would get ourselves in this situation where we are short spaced. against the minimum short spacing rules. And those are the values that you see. I'll go back here to the interference display. If you were short spaced to a station, it automatically switches over to contour to contour. If you're short spaced, you're going to be able to see the separations as shown on our other screen. And let's see here. If I click this little check mark here, it shows us that we have a small overlap here, even at this point, and we have 0, 0. That's looking at the direct line between the two stations, and when it sees short space, it stops. That's a quicker, but not necessarily more accurate methodology. So I'll take that off, and that'll take us back to the default we had, which was, let me get off of there. Which was, now I'm trying to, contours are detailed. Contours are detailed. Now, contours are detailed means that we're going along the 60 dBU protected, or whatever the protected is, if it's a Class B, 54 or 57 for Class B, the interim Class B1. So we look at that contour, and any place where the greatest overlap occurs, we use that as the actual contour distance. So that's what you're looking at when you see contours are detailed. The direct line, like this, direct line overlaps are not very accurate, but they're very fast moving from one channel to the next, and that's why they're still in the program. So let me go back to, let's check for overlaps. We'll go back to contours are detailed. Now let's, just for fun, change this to a C2 and see what happens. Well, immediately we get this flag here that says, hey, if you want to be a C2, first of all, your power is underrated. You don't have the maximum, you don't have the minimum C2 coverage. You have to have at least 39.5 kilometers, and you only have 39.1 kilometers for your average 60 dBU. So you've got an issue here. So it's telling you the class should be a C3. I don't know how well you can read that with the webinar, but that's what that says. And if you click, it says, do you want to operate with 18.902 kilowatts? Well, I'm going to say no, because I know what happens here next. And we get this indication because our power is still the same. We haven't changed the power. And, oh, my goodness, we have these violet colored. These aren't pink. This is violet. So hopefully you're not colorblind and you can detect the difference. It is not a very large difference, but what we're seeing here is that you cannot use these two stations here under 73.215 if you're a C2. You cannot protect them because they won't let you. The FCC says you don't meet the minimum spacings. And if we go back to our spacings map, we can see that, let's go on to auto short spacing. Let's see here. I think I moved the channel. Oh, I'm still on the C2. Let me move back here. All right. So what we've done here is, if we go to the C2, you're going to see these expand, and you're going to be well inside them, and you can't protect them. And so if you operate under auto short spacing, that's going to tell you how far you can intrude into the 73.215 minimum distance area before you start to get into that violet color, which says you can't do it. So C2 would not work under short spacing here. So let's see if there's anything else I need left. Okay. So I'm going to turn it over here to Kate, and we're going to let Kate go through a project. I have one too, but when she's finished, I'll pick up my project. And let's see if there's any questions. I don't see any questions yet, so we can't show you everything, but those are some of the new things, new features. Oh, I have one more to show you. Kate was all ready to go to, and I've got one more to show you, and that is what I'm going to do here is load a pre-made file that I've made. This is KHAM, a great name for an Iowa station. This station was licensed originally as an A in BRIT, and we'll look at it. And there it is without a lot of extra stuff on the map. And we actually moved the station for the client to become a C3. And as a C3, this is our area, or this is our coverage area. And that's a lot more. We've got a lot more population. Well, not a lot more, but we have 16,000 now. Maybe that, you know, that's not a lot when you're in New York City, but it would for a local rural radio station, it's pretty good. Some are a lot worse than that. What they had was this. Look at the population. They had only 2,200 people here. So, all right. So, let's take a look at the. Since this is done as a this was done as a class, let's see, our should be right here. What is our reference? I'm talking to myself now. Okay, this was done as a as the old license. So let's look at the area to locate. And here the area to locate is a very large area. This is for a class A. Let's change that to a C3, which is what we did. And when we change that to a C3, we see that the area to locate has moved down here. So this was a one-step. We went into the commission and said, this is the area to locate right down here. And we moved the station to the south and got a CP for a C3. Whether they'll build it or sell it, I don't know. But what we're seeing here is a situation where this station, and that's this KSTZ, is underlined. That shows us that this station is a C, but it is not meeting the full requirements for a C, so you can actually downgrade it by petitioning the commission. And we did that on another, in fact, in the last webinar I showed you how that was done. So in fact, what we did then is move to this site here. Now I can move to this site simply by clicking to it, or I can go into the mapping screen and put it up on the map. And basically that shows you, again, what I showed you earlier, where it is. So that's how you can use the program to quickly find an area to locate. They're not all that easy, but unless you find that area to locate initially, you can't do a one-step. You cannot short space and use those rules to go to a C3 if you don't have that full area to locate to begin with. So in this case, we had it, and we were able to make those changes. So now I'll go over to Kate, and Kate has got a project that she's going to show you, which shows you a few more features of the program. So let me see if I can do this. Kate.
Can you switch to me, or do you want me to do it?
Okay, I'm going to switch to you as the organizer.
Yep.
I just did it. Did it come to you? No. You're connected to audio. Oh, I want to make the presentator. All right. Presentator. You are the presentator.
Okay, so now you should be seeing a different screen than you did previously. Is that correct, Doug? Are you seeing me now?
Yes, we are.
Okay.
You got to go.
Good. Good afternoon, everybody. Thanks for your time. We really appreciate it. We love these opportunities to kind of give some insight clues into how our programs work. I'm going to show you a quick little 73215 move project that we have. So my main question is, can a station, KNWS, and again, this is an Iowa station, can it move to a different tower? And basically what we're trying to do is we're trying to gain some population by moving to a higher tower. The tower where KNWS is currently located is relatively short, so we want to see if we can move to one of these larger towers and gain some population. So we're going to see if we can't possibly move it to the same tower that KUNI is currently using. So I'm just going to pop over to my FM Commander, and again, I've turned off my auto load, so when it comes up as just a blank screen. A lot of people prefer that. A lot of people prefer that it comes up with the last project that you did. It's really a personal call, however you like to look at things. So I'm going to go to my new study, and there's several ways to get to it. You can use the shortcut, the icon. You can get to it from a couple of different screens. So again, that's just a matter of preference, however you prefer to do it. So I'm going to bring up my station, which is KNWS. And I'm going to look at the licensed facility. And again, I just double click it and it pops up into my reference screen. So I want to move this to my KUNI tower, which, hold on, my coordinates are right there. So I'm just going to pop this in. Oops. And this isn't a huge move. We're only moving it, you know, a couple of kilometers away, but the significance is going to come with the tower itself. Oh, I'm sorry, this should be $7.99. My fault. Okay, one of the things that I know that I'm probably going to want to do, and it's just the nature of FM studies, I'm sure you've all run into this before, it's very rare that you're going to be able to find a fully spaced site when you're trying to move something around or look at something new. So I'm going to start my study assuming that I'm going to have to use 73215 contour to contour protection rather than just a normal spacing study. So I'm going to tell as I compile my study, I'm just going to automatically tell it that yes, I want to consider this as a 73215 station. I can include Class Ds, which are translators. I can include LPFM. You know, these are secondary facilities. You don't necessarily have to protect them, but it's nice to include them in your study so that you can see what effect your move or change might eventually have on another facility. So it's nice to include them just so that you can see them. What are we looking at? So I'm going to go ahead and compile my study. And I'm sorry, I should have had that. Bear with me. Okay, here we go. Okay. So it's going to go out and make my calculations. And it's going to come, because this is on a non-reserved channel, it's going to come up in spacings mode. That's just kind of how FM Commander intuitively works. It sees that your first concern is going to be spacings. So we're going to take a look at these real quick. This is and I should have taken, just a second, I'm going to take this out. Pretend you didn't see this. Pay no attention to the man behind the curtain. We're going to do that later. So this is my licensed facility. This is a new construction permit in Keosauqua, Iowa. I just learned how to pronounce that word the other day. You should all be very impressed. We also have a couple of short spaces with some existing facilities. There's a station in Fort Madison and then a low power FM in Marshalltown. I wouldn't necessarily have to protect this low power FM. It is a secondary facility, but I do want to see it. I do want to know what's going on. So as Doug said earlier, anything that's crossed out with a line through it, that's a facility you do not have to protect. So, you know, again, we just list them so that you can get an idea of what's out there, but you definitely do not have to protect that at all. So the green color here on my screen is the license. Anything that's in the red is eligible for contour protection under 73215, which is what we're going to take a look at. Anything that's in this kind of magenta color does not meet that minimum spacing for 73215. So what this tells us is that we're going to have to do something about Keosauqua if we want to move to this location. So we're going to set Keosauqua aside for the moment and just take a look at the contour protection that we're going to want to supply to the Fort Madison station. Very simple to take a look at that. The icons up at the top, if you kind of hover over them, it'll give you an idea of what that icon means. So we're going to, right now we are in spacings mode, and as Doug showed you earlier, we're going to switch to interference mode just by a click of a button. You'll notice that our columns change from the margin columns to an in and out, and that's incoming and outgoing contour overlap. So we're going to go down here to our Fort Madison facility, and if we take a look at it, now it has that up arrow next to it. That means that that particular facility has been changed to the maximum class for a C2. So if I look at the station information screen, you can see that it's been changed to 50 kilowatts at 150 meters. That's the maximum class for a C2. And the program automatically assigns that max class. Because this particular facility, this Fort Madison station, has not designated itself as a 73215 station. So when you're applying contour protection, you're going to have to protect it at its maximum class. Another way that you can tell that is by these little appendage designators on the call sign. If it has a Z right here, a Z means that that particular station is a 73215 station, and it's using a directional antenna. So as you're looking at your contour overlap, that one will not have this up caret because it's already designated itself as 73215. You only need to protect it at its licensed operation, not max class. Okay. If it has an N in that designator column, right here on Lena, Illinois, that N tells us that it is a 73215 station, but it is an omnidirectional antenna. And if there was a D next to that, it would mean that it is a directional antenna, but not a 73215. So it's using a directional antenna for some other reason, rather than a contour protection situation. Okay. So that's what those little notations tell us next to the license type. Is it a Z? Is it an N? Those are already 73215. They don't need to be max classed. They will not have that up arrow next to them. So that's good to know. Okay. So all I need to do then is take a look at my Fort Madison station. My contour overlap requirements then are met. And I can take a look at that, the contour overlap map, by going to my Find Station Information screen using the lightning bolt icon, and it'll plot the protected and interfering contours based on 73215. So you can tell that there's now no overlap between my proposed facility and my the potential problem. That's been cleared up. So that's good to know. And then I also want to take a look at, okay, I've moved the facility. I've moved it to someplace else. Am I still going to cover the city of license? And I can do that by quickly clicking, going into that Find State Information mapping screen and clicking the bullseye icon, which will automatically plot the city grade coverage. Because this is a commercial station, it's automatically going to plot the 70 dBU. Waterloo is my city of license, and so you can tell that by this proposal to KNWS, I'm going to fully cover my city of license. That's not necessarily, though, what we would consider a coverage contour. So let's take a look at what the 60 dBU is actually going to do for us. So if I go under contour, manually assign, I can change that contour to anything I want it to be, rather than just the city grade coverage. So if I want to take a look at what the 60 dBU coverage is, now this will give me the entire coverage area. How does that compare to where we were? So if this is my proposal and this is my original license, I was at 709, so I gained 68,000 people by this change. And trust me, in Iowa, that's a significant number. Where is that change? Where are those new people? I can change to our compare mode. Basically what that does is it freezes the contour on your screen, and you can add additional station contours as you like, so that you can take a look at what the comparison is. So it freezes it in place. Now I click on my proposal. So my new proposal is going all the way down here and covering most of Iowa City. I'm gaining all of these people. I'm losing a few up here, but this is sparsely populated. It's generally very rural in this particular part of Iowa. So because of that gain of 68,000 people, that's one reason why we would want to consider this particular move. Okay? But I still need to, going back to my original screen, I still need to worry about Keosauqua. So I'm going to have to find some sort of solution to this Keosauqua construction permit. It's a new construction permit. It was just granted, so they haven't really done anything with it yet. It's just kind of hanging out there. The application was filed back in 2010, but it was just granted a couple of months ago. So it is a valid construction permit. I do need to do something with it. Okay, so one of the things that I can do in FM Commander is I can get some more information about that Keosauqua construction permit directly from the program without having to leave it to, go out to the website and, click on a bunch of things and get to the FCC. If I bring up the Find Station Information screen, here I have my construction permit in Keosauqua. We have an icon right here. It's a little black arrow. If I click on that, it's going to go out to the FCC's website, which thankfully is back in business today. I'm sure you all have experienced the same kind of frustration I have in the last couple of days, waiting for it to come back up. And it'll bring up this list of construction permits in Iowa, and I just want to go to my Keosauqua. And I can use this particular FM query screen to get more information. I can look at the application itself. I can actually go in and read the construction permit. So if I click application list and give it a moment, it's going to launch my browser. At least it did earlier. I'll be embarrassed if it doesn't. Nope, here we go. So it'll launch my browser and it'll list the application that we're concerned with. I can go in, I can read the application itself. I can click into info and look at the construction, the actual construction permit. I can see when it was granted. It was just granted back in March. I can just get more information. I can also get the antenna structure registration of the tower that they're proposing to use. Just all kinds of information just at a click, rather than having to go through, get out of this, get into a browser, get to the FCC's website. It just makes it a lot faster. So that's how I can research that construction permit a little bit easier using the tools in FM Commander. So now I want to take a look at the Keosauqua construction permit. What can I do with it that'll allow me to move? But one of the things that I also want to do is I want to make sure that any future study that I do with Keosauqua is going to consider the proposal that I want to do for my station, for KNWS. I want to make sure that that's going to be considered in any future studies. And I can do that by writing all of my proposed parameters to the My file. And if you guys haven't really kind of played with the My file yet or really gotten into it, I strongly urge you to take a look at the manual and get into that a little bit more. It is absolutely essential when you're doing these kinds of what-if studies, because you don't want to lose track of what's my proposal, what am I trying to do. So if I just click this button, it's going to send this information directly to the My file, and it'll consider it in future studies that I do in the area. So we're going to go back to our reference station, and we're going to look up Keosauqua. And I just learned how to spell it. I was very proud. Okay, so here is my construction permit for my C3 in Keosauqua. So if I just double click that, it's going to automatically bring it up. In this particular case, I'm only really interested in, doing a quick study to see what can be done with it. So I'm actually going to take off the D's and L's because it'll just make it a little faster and a little less cluttered. Now this one has designated itself as a 73215 station. It is a Z, which we know tells us that it also has a directional pattern. No. Okay. So we'll go ahead and compile. And we'll call it Keosauqua. Give this a moment to compile. So what we see now is that KNWS proposal that I had is now part of the study because we included it in the My file. So it's automatically going to consider it. Because I know that that's going to be my proposal, one of the things that I would want to do to kind of make things a little bit easier on myself is take out the license. I don't want to confuse the two. So I'm just going to go in, this is the original license, and I'm just going to go under Change and Delete Station. The only reason I do that is I just want to make it as clean as possible. Doug showed you an area to locate just a second ago. I'm going to show you an area to locate. If I had left that license in, it would have made it very confusing. So I'm going to switch to the, this is our spacings mode. Let me get out of Contour Overlap. I did click this. It's being very stubborn. Let me switch back. Okay, here we go. Spacings mode. So the first thing you want to take a look at is the FCC minimum spacings. We do see that then now we do have that short space with my proposal for KNWS. So if I want to make this work, if I want to gain those 68,000 people, I need to find something to do with Keosauqua. So the first thing I'm going to do is take a look at the area to locate map. Where could I possibly move it? So we're going to go to the separations map, and I don't know why I'm so close. Let's take a bigger look. Okay, so here's my area to locate map. This overlapping circle that you're seeing here, because it's different colors, so that tells us that this is a 73215 facility. And it's red and blue, so you know that you're short spaced to it. If it was green and blue and it would be over here, you would clear that spacing. Okay, so one of the things that I can do is I can assign a 73215 spacing to this facility only. So I go under Functions, I'm going to assign a 73215 short space, and I'm going to choose KNWS from my list. So that moved the spacing circle. It also highlighted a little bit so that I can tell that that's the one I'm looking at. Okay, so I am inside that circle. I am too close to KNWS to provide contour overlap protection under 73215. So I need to physically move the facility. So one of the things that I like to do is I like to use existing towers. Finding a new tower is very complicated. So I like to use existing towers. And I know you can also assign the height that you would like that tower to be. I'm going to look at towers that are at least 100 meters high. Okay, so I click OK. This is an optional overlay that's available for purchase. Oops. Okay, don't know why that happened, but we'll get it back. Bear with me. It's going to look like this. I don't know why it crashed, but we'll get it back. Go back to where I was. Okay, I was right here. Now I'm going to go to towers. I'm going to assign 100 meters. And there they are. Okay, good. I was a little worried there for a second. So here's my area to locate. Here's my city of license. And there's a tower right there. So, I would want to propose to Keosauqua that perhaps they move to this particular tower. Bear with me. And that tower is tower 1026019. Okay, so I'm going to propose that we move to this particular tower for Keosauqua. It's going to be fully spaced. Okay. It's going to meet all spacings, including spacings to my proposal for KNWS. So that's good news. They won't have to use an omnidirectional tower or an omnidirectional antenna. I'm sorry, they will use an omnidirectional antenna. They can. So they won't have to pay for a directional antenna to provide that contour protection as they currently do under their CP. Okay, so they're going to move to a taller tower. They're going to be able to use an omnidirectional antenna. The disadvantage is they are going to lose about 3,000 people. So we would have to somehow make this, we would have to make this attractive to them if we really wanted to get this going. So we would have to approach the owners of Keosauqua to somehow make it attractive to them. But it is possible to get this to happen. Okay, so I guess that's all I have on my particular short space.
Okay. Are we done?
I'm done.
All right. Well, let's get it over to my office.
Okay.
And we've got a few things that I want to talk about. So we'll try to...
It should be back to you.
Okay. All right. Can you see it?
Yes.
All right. So thank you for that report. And I noticed that was an Iowa Public Television tower. Not sure they would like that, but maybe they need some money.
It was registered.
Yeah, and when you say we have to make it an attractive deal, that's like a Godfather deal that they can't refuse.
Something like that.
Yeah, just give them 10 grand or something. All right. So I want to move ahead here with a couple of other things that I wanted to show. That's a new feature, and since I was in this program, we'll continue to use that. And notice that this program here has, because I've looked at the other station here, we have an overlap. And so I wanted to look at that by going into the mapping program. This is the Find Information screen. Let's move it up a little bit. And, I just don't like a map that doesn't have anything on it. So let's put a few things on here. A very few. Well, this is rural Iowa. All right, so here's a new feature of the program, and this is you can add user circles. Well, you know, that's not a new feature. Well, it is the way that you can add them. They can be sized, they can be, they'll follow the scale. You don't have to freeze the screen to add them. So you click the add circle, and it's just telling you to highlight the station you want to use. You only see that once. So if we put this on here, we'll see the minimum spacing circle. I don't know if you saw that when it came up. Here's the KFIL station. The minimum circle is 152.5. Now you can put on any circle that you want, and it'll go with a center at the coordinates for these stations here that are shown on the left, as if you've highlighted them. So here we see a couple of area to locate circles, and you notice they're inside both of those. Now we can move back the scale, and we'll see the area to locate and the coverage on the same map. So we're inside of one, we're not quite inside the other. We're inside KTFG. And if you want to put on a user circle on the reference, then you would go into Contour and add user circle. I'll tell you about that in just a moment. The reference circle right up here is what I should be talking about. So, and then you can put on the contour of the other stations if you want by clicking add contours, and then when we put these on, you will see, if they're around, the contours of the stations. Some of them are far enough out that you're not going to see them on this map. The only problem about the contours is the way the program is written now. You have to put them on at a scale that you would accept, because you can't change the scale. It will not scale to the new ones. Once you put the contour on there to your new scale, it won't scale to that. All right, so I wanted to show you that. I also want to go through another situation. I'm going to load another file that was done a while ago. That was one of our clients. And this is a case where we're going to move a translator beyond the crossing 1 millivolt contours, which are part of the rules. You can't move them further than that, except in this one condition. We'll talk about that in a second. But right now I wanted to show you where we are here with the contour that we're going to be moving. This is the old one. This is up in Waverly, Iowa, and note that it's about 11,000 people for a 250 watt translator. And we have an AM station that comes out of Cedar Falls that would like to have that translator. So they purchased it, and we'll look at a different scale here. This is so we can see down here, which is where we're going to move it. So I'm going to put that on the map too. So actually you see down here, a little off the map, but in Hudson, Iowa is where we're going to move this translator and make it a fill-in. Fill-in translators are nice if they're for large service contours, because you can have up to 250 watts, even if you're east of the Mississippi, at whatever height you can come up with, as long as you obey the rules. And the rules are that you cannot, I think I have that as a slide here. Let's put that slide up. So that the outgoing contour must overlap. If it's not an AM station that you're using for the primary station, you would request the Mattoon waiver. The Mattoon waiver is rarely given, but was very popular for a while until the commission said that you can't move a channel at the same time. So the way this works is that if you're moving under a Mattoon waiver, you don't have to cross the 60 dBu contours of your translator from the old site to the new site. However, the channel must remain the same, and that's the gotcha. Also, the old site and the new site must be mutually exclusive. And they do this so you can't move too far out. It kind of limits the move. Now there's a movement by a lot of the AM owners with the help of the Black Coalition in Congress to allow translators to be moved up to 250 kilometers. That is at the FCC, and initially they looked at it and said, well, that looks pretty good, maybe we could do that. And then the opposition fell. And there are so many people against that because they think that what happens is the big stations are going to monopolize these translators because they have the AM stations. So they're going to grab them, and then they're going to be not available to the smaller AM stations that need them in order to survive. So I don't know what's going to happen with that proposal. Going on, there must be no record of previous site moves. They had one guy in the Keys that was moving every week or so, and he had a little trailer, and he'd pull up the antenna on this trailer, and he'd transmit, and then ask for an STA, and then he'd move it again. They really they threw the book at him, basically. So he's out of the business of translators. They won't allow him to apply for any more. And then you have to obey the outgoing contour overlap rule with your translator. That's the 73509. You cannot cause contour overlap with any station or other translator. However, as you know, translators can receive contour overlap. So we have this, how far can you move the translator within the AM coverage area? And the answer is the FCC has stipulated that you have to draw the 2 millivolt per meter of the AM transmitter, and you have to move your translator so that it's inside of that, or a 25-mile circle, whichever is smaller. So we're going to go through that process now, and we'll take a look at how this is done. So what I want to do here is I have both of these on the map. What I'm going to do here is put up the translator location. All right, and then we're going to actually put on the AM. Now you're going to say, well, I didn't know you could put AM contours on the FM program, and the answer is, well, this isn't Probe. Probe you can do the, or AM Pro I should say. AM Pro does all of that, and it puts the AM contours anywhere you want to. But AM Pro will also make a distance to, we call them DTC contours, a distance to contour file. And that can be imported in FM Commander. So if you have AM Pro, you're all set. If you don't, you can talk to Kate, and for a nominal sum, she'll make you an AM contour, which you can import. So in this case, I've already made one with AM Pro, and I'm going to import it. And this is the load DTC or plot file menu item. DTC is the distance to contour. A plot file you can make with some of our other programs like Contour. If you are using, you might want to truncate certain contours that you have in a given station that looks into the ocean, for example, and that will affect your HAT sometimes in a very positive way. Well, you can truncate those contours and then import that into FM Commander. In this case, I'm going to change over to the folder where I am, and it is right here. And I've got the KCFI, that's the AM primary, 2 millivolt. Okay, so there it is. Well, it's too large here. It goes off the map, so we'll change the scale. The scale will automatically track with the contour will automatically track with the scale. All right, so here we are. So we're well inside the 2 millivolt. How about this 25-mile contour? So we can go down to user circles, and the last user circle, well, we'll add a user circle. The latitude and longitude of the last AM station that we put on will automatically appear here now in the user circle. User circles, you can type in your own latitude and longitude if you want to, and it'll put a circle at a certain diameter. In this case, we're going to use the coordinates of the AM station, and now it's asking for the radius. Now, this is a new twist that's been added. You can put in miles as long as you put in an M. So it's 25 miles. It's something like 40.1 kilometers. It's 25 miles. And I never can remember that. So now here's the 25-mile circle. And if you want to be very creative, you can label this as such. And we'll do that. And so now if I right-click this little label on the left-hand side, right where it starts, I can move it around just like another label. So that's what I did there. So now we have an area to put our translator in, and we can move under the Mattoon waiver, and we're right in meeting the FCC rules. So that's how you would you can print this out. You can print your FM over out for your translator relationship. Now we can't have any outgoing interference. Do we have some? We do have some with KOKZ, and we have outgoing contour. And this is a third adjacent translator. So we have to show the FCC in some type of a procedure or some type of a narrative that in your application you're not causing interference. Well, one thing you can do is, oops, we'll go to here, is you can take a look at the, if you have the mapping feature, you can take a look at the actual, let me see if I have this right, set up to Google Earth. And it's going to come up. It's taking its time today. Kate says this makes her nauseous, but yeah, she says it does, but it doesn't bother me at all. Well, I've got two of them on there, so I'll take this one off. All right, so we're really looking at a different program now, but we've done a, we've kind of tied the two programs together. This brings up the tower site. If I zoom in here, you can see how populated the area will be. So if it's a third adjacent, I'll just zoom in here. So we can all take a look at the tower site. Well, you can see that there's a little bit of difference here. If it's more than 1 second, you better refile with the FCC to change the coordinates, the license coordinates, and you'll have to do that through ULS and antenna registration. They can give you a ticket, and they've been to Des Moines and met the broadcasters there and said that they're going to look at their Google Earth, and they're going to determine where it is. Google Earth is very accurate. It's surprisingly how accurate it is. So here they are, and if you look at the area around this area, you can see that there's hardly anybody. Closest house might be here. These look like pieces of snow. Closest house would be here. So you can't put a certain signal strength based on U to D over this area. And I won't go into that because we don't have all that time to do right now. But we have a program called XField. which really makes it easy to determine whether there's going to be a problem. I actually will show you one thing here. So I'm going to discard this now. We know how far out it goes. You can actually measure that with the measuring capability of Google Earth. And I'm going to go into the Tools menu, and I'm going to store the reference DAT. And I'm going to go to my, where is it here, my other program. I'm going to bring up the one I said I was going to talk about, because I'm not going to talk in depth about it, but I will mention a few things. This is Xfield. I know some of you have this. And so you notice now that built into the program, when I saved it to the reference DAT, it automatically loads the file. And I know that we can get about, this is a 500-foot tower, we can get up there about 140 meters. And then you want to put in the station that you're protecting, in this case, KOZY. So we'll browse to it. And we'll accept it. And we'll enter it. And why is this? Oh, KOKZ. I have the wrong browse. KOK. Sorry about that. It looked strange when I saw that the distance was a long way. Yeah, this looks better. So it's 28.8 kilometers away, and our field strength is 84.2 at the translator site. So we can have 40 dB above that. So we can have 114, is that right? 124 dBu. That's a lot. That would never reach the ground. We can look at this. We have to order. You can put a vertical field in here. So if you have an antenna that has a vertical elevation field, let's put in a tube A. I'm just pulled this out of a hat. And then if we look at the table, enter the city and the state, and this will bring up the table. Where is it? Got a lot of things going here on this computer. It's taking its time. This is a Vista computer, so it has a few issues. I'm too cheap to get a new one. So, all right. Well, anyway, that's what I was going to show you. There's a real nice table that shows you how high the contour is at a given distance, horizontal distance. And if it's too low, if it's within 10 meters, if it's within 5 meters of the ground, and there's a home there, you've got a problem. So I don't know why just still have Google Earth going here. So, and GoToMeeting. So that's probably one of the reasons that program wouldn't just come up with our table, because the table actually shells to Notepad. All right. So that's how we do the translator thing. One thing I wanted to show you that's fairly new is if you go over to the database screen, I just clicked the file drawer here, and you go into listing query and go down to filter. What we're going to do here is we're going to filter, and I've turned the filter on. You're going to use the reference latitude and longitude. That's this one up here. If I would use anything else like the data that I brought up on a given station, in this case it was this K201CJ, then I wouldn't use the reference. I would use this value for coordinates. So I'll use this, and I'll say I want to see every station within 20 kilometers. And then if I click OK, I can actually reject certain aspects. If I click OK, now the database will be filtered. And the first thing it does is show you an unfiltered database other than the distances that you've selected. So you've got all the stations that it found within that distance here. So mostly Waterloo and Cedar Falls stations. By the way, if you hit one of these stations, double-click them somewhere, it'll bring up the whole station that you can refer to. And if you click Review, that'll take you back to your list. So you can actually look for something on the list and go and see the more detail by going to the database handling screen. So enough of that, but if you go over to listing query, and you say, well, now I want everyone within 25 kilometers, that is a, let's see, that is, what's a good one? That's a Class D or a Class L. Why don't we use, let's see, I'll use the service designation, and I'll put in a D. L would be low power, FM. And so that would pick up anything it found. And it found new. That's the first one it found. It's a Class D. It's an L, rather. So let me see here. Let's go to licensee and pick up didn't spell that right. And I picked up University of Northern Iowa. So you can filter again and then add a filter based on the listing query filters that are available. So there we go with that. So I'm going to take some questions now if anybody's got any. We have about 10 minutes left. So if you have some questions, otherwise I can show you a few other things. But go ahead and type them in, and both Kate and I will try to answer those. So any burning questions? Okay, well, I don't see any coming up at the moment. So I will show you this. If there are any come up, just go ahead and write them in. I'll read them as they come up. I'm going to move back to the commercial screen here. By the way, translators are contour to contour, very much like you would have with any contour to contour relationship that would be non-commercial or 73215 protections. So I'm going to go back to this separation map here, and then what I want to do here is show you what it looks like when we put it on Google. Now, well, actually, this is going to be on Acme Mapper. I see that I had this selected for this screen. Acme Mapper will actually bring up a map, which is a topographic map. So if you really want to get accurate and read off, well, I don't know how accurate they are anymore compared to Google Earth, or something like a 30 arc second, 30-second database. No, I'm thinking of the 30, why can't I think of it?
30 meter.
Anyway, 30 meter, thank you. I knew there was something in 30 meter. So if you use that, you'd actually, my wife comes up with words for me occasionally too. So let's move out of this. Notice this was a shell out, but if we actually change the functions to, should be able to do that over here, to Google Earth. Let's see. I need to be on this screen. Oh, it is Google Earth. So, oh, by the way, we can also bring up Google Earth right from here. So if you want to see the transmitter site of any of these, you can just click this button here, and I will show you that translator site. I think Google Earth was already up. That's probably why we didn't see it there. So let's go back to where I was. And having trouble replicating, Tim Warner, replicating filtered listing query, getting a runtime error. Can you show again? Sure. Just 1 second here, see if this Google Earth thing works, and we'll do that. Okay. It's here. All right, well, where am I looking for it? I'm running out of steam here. I think that's the problem. That's why we make these things only an hour and a half long, because we run out of steam. But should be right here. Sometimes I look at it and it's not even right there. I mean, it's right in front of my eyes. Right there is where it is. It was right in front of my eyes. Tim, just restart your program. I think you might have, there might be an issue with that. So go ahead and restart the program and then I'll show you. All right, so here's your area to locate on Google Earth. So I just wanted to show you that. And just to give you the, we're running out of time here, but I'll try to be as brief as I can. You go into File, I'm sorry, you go into the Database Handling program by clicking the file, click Filter, click Use Reference. In this case, we're going to find all the stations within 25 miles of the reference, which is over here, and 25 kilometers. And this should give you a list. So that gives you a list that's unfiltered. And then you can go in and filter it even further by going into any one of these. So anything you do now is going to be filtered by the 25 kilometer distance. So you're not going to get stations outside of that if you go in and do a listing query. Let's go out to 75 kilometers. So if you go into the base list now and I've typed in a licensee name, or at least the start of it. Here we have all the University of Northern Iowa, and they're all within 75 kilometers. So that's how that works. So in any event, I don't see anything else up here. 30 meter, thank you, Michael. Michael Brown tells me that what I couldn't think of there. And so that is the webinar for today. We have on next Tuesday at the same time and same station, John will be here, and John and I'll basically introduce it. I'm going to turn it over to John and let him do almost everything, you know, the rest of it. So he's the real expert at knowing all the little things that you need to know for Probe 4. And then on Thursday we have Microwave Pro. If you're still interested in sticking around for that, there's a lot of things to be learned and a lot of exciting ideas that the new Microwave Pro 2 incorporates. So at that, I will say goodbye and thank you very much for signing up for the webinar today. And we'll turn our things off. If you have any thing that you would like to email in terms of a question, please email us. You can email us at info@v-soft.com. So thank you very much and good night.